So students, welcome back to this channel of mine where I try to make mathematics a bit more fun. And today we are once again going to be continuing our continuity and differentiability series. And today we are once again going to focusing on practicing a few more questions. In the previous video, I think I practiced one question and taught you what was the formulas and where do they come from. The first identity I taught in the previous video was this limit of x tends to 0 of sin x over x equals 1. What does it come from? I think comparing to the to what I taught you guys yesterday, there can be a better explanation of this. Actually, rather than focusing on just quadratic questions, let's try to find out what this can come from. You know that what is the hospital rule? It says that if trying to solve a limit problem by directly plugging in the values of the limit into the function will give something undefined, something indeterminate, then we have to take the derivatives of both the numerator and the denominator. So what does that basically mean in this? This would be the same as limit of derivative of sin x ddx of sin x over ddx, meaning differentiation of this function with respect to the variable x. This two will be the same thing. And derivatives of sin x with respect to s, we all know that is cos x, and derivative of x to the with respect to x is 1, where x tends to 0. Now plugging in 0 for x would give us cos 0 over 1, and cos 0 is 1, so we get 1 over 1. That is it. Now I think it would be really interesting for really helpful as well for me to prove this LSP rule. Otherwise, as I've told you guys, I just don't want to make mathematics seem like I'm here to help you guys memorize a few formulas and try to find a few patterns with them only. No, I have to make everything make sense here. Okay. Let us try to prove the hospital rule right now. First of all, I would recommend you watching my previous videos about calculus before you want to continue this video, because hospital rule involves derivatives, and of course, in order to understand them, you will need to understand how this differentiation work. Okay. What is really actually the essence of differentiation? What is differentiation actually? So I would definitely recommend you guys watching those videos of mine. Okay, now coming back to this topic, let's say we have a function of x, that is fx, over a function of x gx, and if we evaluate both functions at point 0, we get 0. F of 0 is 0 and g of 0 is also 0. So limit of the ratio of these two functions where x approaches 0 would be 0 over 0, and this is, as I told you guys already, this is the indeterminate identity. So in mathematics, you just cannot accept this as an answer. This would never work, because 0 over 0 is an indeterminate number. If it's not a number, we don't know what it even is. You can basically think of this as the 7 deadly sins, one of the 7 deadly sins in mathematics. I would definitely talk about the other ones in a future video of mine, but for right now, Just keep in mind that whenever we see something like 0 over 0, yeah, this is cursed, and this we just want to avoid this as much as possible. Okay. Now, how do you even approach? How do you even solve this? We can rewrite this as limit of x approaches 0. Instead of this, we have f of x minus 0. We can write it like f of x minus 0 over g of x minus 0, because this does not change anything. Initially, we had f of x over g of x, and now we are just subtracting both 0 from both the numerator and the denominator. That changes nothing. Now, we can rewrite this as limit of x approaches 0 of f of x minus, we can rewrite 0 as f of x, because we know that f of x evaluated at 0, that is f of 0 is 0. So this can be rewritten as f of 0, and in the denominator as well we can do the same. This can be rewritten as g of x minus g of 0. Okay. Now we can rewrite this as limit of x approaches 0. What I'm going to be doing here is basically we're going to be dividing both the numerator and the denominator by x minus 0. We can definitely do that because we know that multiplying or dividing both the numerator and the denominator would not change with the value of any fraction. So you can rewrite this as f of x minus f of 0 over x minus 0 over g of x minus g of 0 over x minus 0. Now we also know that limit of a fraction uh, it's the same thing as fraction of limits. I mean, you can basically think about how this works, because you're trying to find the limiting value of this expression. So of course, trying to taking the limits of the numerator and the denominator individually would not change anything. I hope you can see what is going on here. First of all, don't laugh at anything, Karna. I know it looks terrible, but I mean, there's nothing I can do about it. Uh, I just want to like really curse my barrel right now, but I cannot do that. Anyway, we can rewrite this as limit of x approaches 0 of f of x minus f of 0 over x minus 0 divided by as limit of x approaches 0 of f of x minus f of 0 over x minus 0. Sorry, actually, in the denominator we have g sort of x, g of x minus g of 0. Now, don't lie to me, considering you have watched all of my previous videos about calculus, you have definitely seen this before. This basically looks like, where do I write this? This looks like as limit of x approaches, as limit of h approaches 0 of f of x plus h minus f of x over x minus h. No, actually it would be h minus x. These two look pretty similar. So what we actually did here is that this is basically the formula of differentiation here, where uh, the base value we are gonna be uh, taking from the point we are going to be calculating the rate of change is point 0. So this means uh, this can be rewritten as, where do I write this thing? Let's write it here. This is the same as derivatives of that derivative of the function actually. I'm not going to get deep into this, like why differentiation looks like this. Why is differentiation defined as this? I would definitely recommend you guys watching a previous video of about calculus if you are not able to understand what has happened here. For now, this becomes f prime of x, f dash of x. Basically, that is uh, rate of change of this function f of x over g dash of x, rate of change of function g. Okay, and that is it. We can again apply the limit in front because we are trying to approach this value. So putting the limit over here would not change anything. Okay, this is basically the proof by hospital rule. I know that this should have been taught in 11th standard, but first of all, I have not taught you guys about 11th standard, anything about that. And secondly, I think uh, you just I don't think you probably even understand why hospital rule even works. I have to give my best try to explain it. This would definitely come in handy. Not just for 12th standard, for like computers as well, but for any fields of mathematics from now on. Now let's try to solve a question. Uh, we have been asked to find the discontinuous point of this function, discontinuous points of this function. F of x is x plus 2 over 2x square minus x minus 1. This is discontinuous at points our options are a 1 over 2 comma minus 1, b minus 1 over 2 comma minus 1, c 1 over 2 comma minus 1 over 2. So it's actually 1 comma minus 1 over 2, and d 1 over 2 comma 1. Okay, now let's start solve this. How would you do that? We would first, the only way we have here is the only option we have is option testing. So let's start to solve it that way. First of all, let's take first of all let's check out the function what we have here. We can see that first of all, the very first thing that should come into mind, that when we plug in 1 for x, we get 2 minus 2 in the denominator, that is 0. So definitely seeing if the function is discontinuous at point 1 would be definitely be helpful. So That is the first thing we're gonna be doing right now. Okay, let's see if this function is discontinuous at point 1. As limit of x approaches 1 of this function x square x plus 2 over 2x square minus x minus 1. Now we can differentiate both the numerator and the denominator. And this would be as limit of x approaches 1. On the numerator we are going to have 1 and denominator would become 4x minus 1. Now if you try to plug in 1 for x, we would get 1 over 4 times 1 minus 1, that is 1 over 4 minus 1, that is 1 over 3. And now the functional value of this function at point x would be, as I told you, is going to be undefined. It's going to be 1 plus 2 over 2 times 1 square minus 1 minus 1. That is going to be 3 over 2 minus 2. That is going to be 3 over 0. That is undefined. This is undefined. Okay, so this means we saw that as limit of x approaches 1 of this function f of x, it's not the same as functional value at point 1. This means definitely one of the points in which this function is not continuous is going to be 1. So that means these two options, first two options, A and B, get cancelled out at the very first, because neither of these two options have positive 1 in them. So the options we are left with right now are these two options, A and option D. So, and the difference between these two options is that the other point they are saying is the function is going to be discontinuous at, is where these two options differ. So let's see. Let's see if this function is discontinuous at negative 1 over 2. As limit of x approaches negative 1 over 2 of f of x, it's going to be limit of x approaches negative 1 over 2 of this function x plus 2 over 2x square minus 1, sorry, 2x square minus x minus 1. This would be x minus half plus 2 times 1 over 4 minus 1 over minus of that would give us plus 1 over 2 minus 1. This would become, in the numerator we're going to have 3 over 2, and the denominator we would have 1 over 2 plus 1 over 2, that would become so that is going to become 1 over 2 plus 1 over 2 minus 1. So in this point as well, we have 3 over 2 over 0, that is undefined. So this means we have to take the derivatives here as well. And first of all, you can easily see that since this is undefined, this function is undefined at negative 1 over 2, so this is obviously gonna be discontinuous at that point. So you can definitely say that this is discontinuous at this point. But for the sake of learning new things, we're gonna be trying to solve this normal way as well. I mean, if you're like talking from exam perspective, I would definitely recommend you guys just stopping at this point and saying that option 3 is correct, because that is the correct option. Now, taking the derivatives of both uh, the numerator and the denominator, we would be left with, as x approaches negative 1 over 2 of 1 over 4x minus 1. Now, plugging in x, half minus half of x minus half of 4x would give us 1 over 4 times minus 1 over 2 minus 1. So this would be the same as minus 2 minus 1. So this would be 1 over minus 3. Or you can write this as negative of 1 over 3. So again, as limit of x approaches minus half of f of x is not the same as if evaluated at negative 1 over 2. So this means this function is definitely discontinuous at point negative or 1 over 2. So the answer is option C. 1 and negative 1 over 2 are the points in which this function f of x, which is x plus 2 over 2x square minus x minus 1, is going to be discontinuous. Okay? This is where I would like to end the session. I think there will be like 1 or 2 more videos of this series, of this chapter actually, and then it's going to be over, because this I would say is probably one of the easiest chapters of this of our entire 12th standard. And as always, if you guys think that you have any doubts regarding anything I have taught you guys today, you can definitely let me know about that in the comment section. I would try to resolve your doubts. Until then, keep learning.